Hi guys, so today I'm going to be talking about kinematics, specifically kinematics in relation to projectile motion, which is when you launch something off of the surface, this is the surface, and you launch it from the ground in a certain angle, and it moves in a parabolic motion, which is kind of like forming a big hill, like that, until it goes back to the ground. So to simplify the analysis of this parabolic motion, we would have to look at the horizontal component and the vertical component of it separately. So let's start off by talking about the vertical component of the parabolic motion. The equation for the vertical component is delta y equals v naught times t plus 1/2 at squared. There are two things that you need to know about the vertical motion that holds true for all types of projectile motion problems. The first is that since it's the vertical motion, acceleration, unless otherwise specified, is equal to gravity, which is, in Earth's case, 9.8 meters per second squared. The second thing is that at maximum height, or the point like when it's moving in the parabolic motion, the highest it goes right before it starts going back down to the ground, the velocity at that certain point is always going to be equal to 0. Now we move on to the horizontal component of the parabolic motion. The equation for the horizontal component is basically the same, except it's delta x, not delta y. So the equation is delta x equals v initial times time plus 1/2 at squared. However, since there is no acceleration in the horizontal component, the equation for the horizontal component can be simplified to just being delta x equals v initial times time. Now that you know the equations for both the vertical and horizontal components of the parabolic motion, let's try using them to solve a practice problem. An object is thrown horizontally off a cliff with an initial speed of 10 meters per second. How far will it drop in 4 seconds, assuming it does not hit the ground first? The first step is to figure out whether they're asking a horizontal question or a vertical question. Since they're asking how far will it drop, this is a vertical question, meaning we would have to use the vertical motion equations in this case. Now, the problem also states that the ball was thrown horizontally. Because of this, that means that the vertical component of the initial velocity of the ball equals 0. So the value we would substitute for v in the equation delta y equals vt plus 1/2 at squared would be 0. Since v equals 0, the v times t part of the equation cancels out, so we are left with delta y equals 1/2 at squared. A, as I have mentioned before, equals gravity, and so we would just substitute 9.8 meters per second squared into the equation. However, in this video, I will be using 10 meters per second squared as a value just to make the calculations easier. Also, the value of time was given to us as 4 seconds, so we would just have to substitute that value in for t. So after plugging in all the values, we get that delta y equals 80 meters, meaning that the ball dropped 80 meters in those 4 seconds. So thank you for watching my video. I hope I helped you understand kinematics a little bit better. I'm sorry to tell you this, but it only gets harder from here. But I wish you luck in your physics endeavors.